Hello everyone. Let's continue our next lecture series in the divide and conquer strategy. So in the previous lecture we have seen binary search method and we have seen how the divide and conquer strategy applicable to the binary search, what is their advantage compared to the sequential search, what are the common mistakes that were done during the example solving, and then how to find the complexity. So in this video lecture we are going to see the next in the divide and conquer path, that is the merge sort. So let's revisit what is the divide and conquer. So divide the problem into subproblem, then recursively solve the sum problems. Once the problem will be recursively solved, you have to combine their answer. That is what the divide and conquer strategy. Now the next technique that you will be going to learn after divide and conquer is the dynamic programming. The dynamic programming also do the similar things, that is divide the problem in subproblem, solve the subproblems, and then get the result. Then what is the key difference between the divide and conquer and the dynamic programming? So let's take one example and then through which we will try to understand the difference between these two key algorithm techniques. So in the previous semester we have used the project based in the database management system. So consider there are 4 students in a one project and the given task will be divided in 4 parts. So consider there is a students A, B, C and D. So there will be 4 parts. So all are going to solve the problems, get the result and then combine the answer. Now consider a different scenario in which a student B have to wait for a student A to complete the task, and then once the student A complete the task, B is going to utilize that answer to continuing the result. That is we call the dependency. So when you use the divide and conquer, you have to make sure there will be a no dependency in the subproblems. So if there is a dependency in subproblems, then the divide and conquer strategy will become more complex. So that will be continuing more and more depth, again solving the subproblems, because they assume in the divide and conquer that the subproblems are independent. So if you have problems in which the subproblems is interdependent, in that case don't use the divide and conquer, you can go with the dynamic programming. So keep in mind that based on the problem statement, based on the requirements, you have to select algorithm techniques. So in our revisit to divide and conquer, let's continue with our next example, that is the merge sort. So now we have start with an original sequence. We have to sort the array. So total there are 8 elements. So first we divide the array in half. So that is what our divide part. Again half part will be divided. Now again the first part, that is you can see recursively, that is going to be called, again is divided in half part 2 and 2. So here you can go with integer divide and then you can continue. Now again this 2 will be going 1 part. So right now what you see in example, the exact same recursive code will be made when you write a program of merge sort. The exact same way it will call this part, then call this part and this part, then get the answer, then this part, get the answer, then this part, so and so on. This is the exact way of a recursion call when you are implementing a program. Okay? So one program, one element that you, so it means you have to continue a sub problem till you have an element of size 1, and when you have only one element in the array, it means it is already sorted. You don't have to go in more depth to divide the one element. Okay? So that's, you can say, it will be our stopping conditions, a recursion depth. So 2 again 1. So now from here this 18 will be start. This is what the merging part, this is divide part, solving here, and then the conquer will be part, and the last combined part will be continue. Next the 26 will become here, 18 and 26 both will become here, and then this 18 and 26, first they are going to merge, because in the recursion, if you're calling a sub problem, then the first sub problem will complete, then the next call will be done. So till you don't do the sorting of these two things, this part, then you tell that you are not able to call this part. That is what the recursion do. So 18 and 26. Now this is a combined part. So ultimately you have a two sorted arrays that you have to combine in one sorted arrays. That is what the merge, that is the requirement. So that's, we will have a separate example to go in depth. So 18 and 26, 18 26, again 32 and 6. So again it is going to be one element here, 32 here, say, and then 6 will come in the picture, then so again 6 will come. Now this both will be combined, so both will combine in a one sorted arrays, that is 6 and 32. Yeah. Now again this is one sorted arrays, this is another sorted array. Now you have to combine these two sorted arrays into one sorted arrays, that is 6, 18, 26 and 32. Yeah. Now again this is two part, divide part, again one part that you are going to call. Yeah. The 43 will become first, then the 15 will come, then now you have to merge these two sorted arrays, so that will be 15 and 43, and then again continue 9 and 1, so and so on. Again 9, again 1 will be called afterwards, then 9 and 1 is going to be merged, that is 1 and 9, again both are going to be merged, this sorted and this sorted array, so 1, 9 and this, so and so on. So now this part till now, this is we have done, again going on upward. So now we have a two sorted arrays that we are going to combine. So 1, 6, 9, 18, 15, 26, 32, 43. That is by the exit layer. So now this is what the working of merge sort. Even we will also look at it, that how, if it was asked in the exam, how the students can able to write down in the exams. Okay? So this is what the sequence of a merge sort. You will given n elements in the one order. You have to find a particular permutation of that array, that is in an ordered sequence. So now first part will be given an array name and p and r. P will be the starting index, r will be the ending index. So this moment when p is less than r, it means you have to stop. Otherwise this is a flooring, p plus r divided by 2, the similar thing that we have done in the C language, that if you implement this code, just you can write p plus r divided by 2, it will be done. And first we have to call this part from p to q. Once it will be done, that is q plus 1 to r. So in our example, let's go, this is from p to r, the q is in between, so this p to q and q plus 1 to r, that's we are going to call, this is p to q, q plus 1 to r. And once we both have done the sorted part, then we have to merge. So ultimately we are merging a two sorted arrays, one is from p to q, second is from q1, q plus 1 to r. So this two sorted array we are going to merge. So this is the main call. Now when we are going to call, we have to call using these functions, merge call a1 comma n. Now generally in C language, when the index will start with 0 index, then you have to start with 0 and n minus 1. So accordingly you have to change it here. Now the next part, that when you are given two sorted arrays, how you are going to merge it. And this is one sorted arrays, this is another sorted arrays, this is my a, so this will be the index. So here for this array I will give the index I for j and a will from k. So ultimately if you can see, essentially this 4 element will be here, this 4 element will be here. Now in order to define the end of array in this token, we use the sentinel. This is we call the sentinel. So this will be the, you can say, the highest value that is possible, and that of course you are not going to utilize the array. So this highest value will be used as a sentinel, or any other value that you can showcase that it's the end of array. So in the programming, if you are, let's say, assuming that fine, you have all the positive numbers that you are going to use in the sorting, so you can use some negative value here, or use 0 or any other, or some, what is the highest positive integer that is possible, that you can try to utilize here. But you have to make sure that this is not the part of array, it is just a showcase the end of element, because every time the size of this L and R is changing. Okay, maybe in this call it is 4 4, maybe another call it is 8 8 or 2 2 or maybe 1 1. So every time the size of this array is changing, but this is always denotes the end of array. So as we have seen here, this is P to Q and Q plus 1 to R. Ultimately the index is P to R. So if we want to denote with this particular uh, index, this is my P, this is my Q, and this is my R. So one array from P to Q, second array from Q plus 1 to R. So now this is my P, this is my Q, this is Q plus 1, and this is R. Okay, so now given this A of P to Q, Q plus 1 to R, how to find the size of this array? That is the first step in the algorithm. First you have to find the size of this array. The second step, once you got the array, you have to copy from P to Q here, from Q plus 1 to R. That you have to copy in this L and R. So once you copy the element, the next step will be add the sentinel. This is the next part, the sentinel. So now let's say for the sake of this is we define n1. n1 will be the number of elements in L array, and this is n2. So n2 we define as the number of elements in R. So n1 plus 1 will be the index of this element, n2 plus 1 will be the index of the sentinel in the R. Now your algorithm will begin. So first thing, obvious conditions, you have to compare L of I and R of j. So whichever is the less value, that particular index will be going plus. Now apart from this j, the k is also going to plus, because this element going to be copy, or whatever the element that is here going to replace it. So 1 will be copy here, then j will be pointing 9 and 6. So out of 6 and 9, the element smaller is 6, so 6 will be copied. So 6 will be here. The moment 6 will be here, I is also increment and k is also increment. It means if we were to get sorted analysis in the merge sort, at any point of time, either I or j is going to be increment. Not both is going to be increment at the same time. So if the condition true, one will be increment. If condition false, the another will be increment. But this k value, that is going to be increment every time. Okay, so use this thing in a programming. So first thing what we have done is we have defined two array P to Q and Q plus 1 to R. We have to calculate the n1 n2, then we have to copy the elements from here to here and the remaining element from here to here. That's we have to copy. Once we copy the element, once we copy these elements, then we have to add this sentinel part in L and sentinel part in R. Once this part is done, the main merging process will start, in which you have to compare L of I and R of j. The k will be pointing here, so your k will be P, your L of I will be here P, R of j will be Q plus 1. That is the way it will start, and then you have to compare. So till you won't get the sentinel index, you have to be continuing comparing with each other. So every time either I or j is going to be increment, but the k is going to be increment every time. Okay, so these all are the steps that will be useful in designing a program of this particular sorting. Okay, the merge part. Now 8 will become in the picture, that you can see 8 and 9, again 8 is less than, so I will be increment. Now 26 and 9, so of course 9 is the less value, so 9 this index will be increment, 9 will be passed here. Again 42 and 26, so 26 will be less than 42, I will be increment and the k will be increment. 32, that will be less than the 42, so again I will be increment, 42 will be there. Now the next value will be the sentinel, so the moment I will reach to the sentinel, it means every time the condition is going to be checked, but every time this will gain advantage, because this value will be always be less than this one, but that will be a stopping criteria. So now all the remaining values will be copy paste here. Okay, so this is what the algorithm numerical, as we have discussed in the previous lecture. And the methodology that I'm going to employ it in my class is that first I will start with the numerical, go in the different cases of the numerical, and from the numerical we have to design the algorithm. That is the best way to remember the algorithms, to remember the example, and to work out. So now this all K, I, J, L, R, A, N1, N2, P, Q, R, all we are going to use in the merge part. Again, remember that merge is not the recursive part. Merge sort is the recursive part. Merge is a sub part of the algorithm in the merge sort, but merge is not a recursive part. Okay, so maybe we are going to be in finding out what is the complexity of this thing. Okay, let's discuss the code and then we again come to the part of merge part. What is the complexity? Because we have to find the complexity of recursive, this merge sort. And if you want to find the complexity of any recursive program, then you have to check out how many recursion calls are there, what is the complexity, what is the size of input in all the recursion calls, plus what is the non-recursive part. Because in the recursive program, of course, there are certain sentences that are often non-recursive, they are iterative part. So you have to find the complexity of that, and then ultimately you have to find a recursive equation of a particular sorting or any other problem statement. Okay. So the inputs are, you can see, a one array is from P to Q, another is from Q plus 1 to R. So that's why the output is this, the output will be merged from P to R. Okay, so in the first part we have to find the size of L array, that is the n1. So again let's go to the this, that is what we say n1. So that is P, Q and R. So find is the P, Q, R is the index. So Q minus P plus 1, that is what is my n1. So this will give me a size of L array. Now n2, this will give me a size of my R array. The moment I got the size, it means I will start copying the elements from the array A to the L and R. So n1 is for L. So you can see this will come in the picture. So one by one element from P plus I minus 1 that I have to copy in I, because my index starting will be P, Q and R. So that's why everywhere you will see in the picture that is P, Q and R. The moment first part will be done, I will start with the second part, that is from j equal to 1 to n2, and then they are going to copy paste here. Okay, so in this algorithm they will assume the index start with 1, so that's why they have started with 1 here. So if you are assuming in terms of C language that your index will start with 0, sorry, and then you have to replace here with 0 to n2 minus 1, and then you have to continue in that. So this will upload this 2, and once you complete this part, copy paste, you have to add the sentinels. This is end of array, that's you have to replace this with a value when you are doing in terms of programming. So n1 plus 1, n2 plus 1, that is sentinel. Now once this will be over, you have to start the main part. Now the question is, what is the size of that for loop, that from where to where you are going to do? Of course you are going from here, start with the ij, you will start because that is the index for L and R. The main for loop, that is start from P to R, because ultimately your output will be this sorted array. So P to R. Now first thing you will compare whether the left value is less than equal to right value. If answer is yes, well, copy the left value and improvise the I. Okay, otherwise you will copy the right value and continue. Okay, so now this will be the your entire code of merge. Okay, well, I think I missed something, right? Yeah, I have increment I have increment K. What about J? Yes, that is line number 16 will be there. That is the J plus 1. As I told, at a time, if the condition is true, this is going to be increment. Condition is false, this is going to be increment. But the K value is going to be increment every time. Okay, so this will be the entire code of merge. Now we may want to find the complexity of this merge. Now you may want to ask, well, how to find it out? Well, if we take all the values, because at the last merge will be called for the two sorted sub arrays. Okay, So in that case, this for loop will be going to access each element once. So let's go to the again example. So if again, okay. So this merge I am calling this part and this part. When this merge will be called here, ultimately they have to visit through all the element. And how many element in the array that we are assuming? We are assuming there are n elements. So the complexity of merge is big of n because they have to access all the elements. So because merge is an iterative part, there we are going to do it. So this complexity of statement 5 is 1. Now what right now how many recursion call we are going to do it? So first recursion call here, second recursion call here, only two recursion call. Now as compared to binary search, because in the binary search also there are two recursion calls, but at a time only one is going to call while second is not going to call. If one is called, second is not called. If second is called, one is not called. Now can I say the same phenomena is also applicable in the merge sort? Well, no, because there is no any conditions here that if this statement 3 is execute, 4 is not going to be execute. If 3 execute, 4 is going to be execute. Okay, so out of these 5 lines, the line number 3 and 4 both are recursion calls, while the line number 1, 2 and 5, these three are the iterative calls. So the complexity of 1, 2 and 5 combinedly is big of n, and the 3 and 4, well, now we have to check out what is the size of the array that we are going to call in both the cases. So if the size of this array is n, then again this will be n by 2 because we are going the half. This will be also going to n by 2. It means there are 2 times we are going to do the recursion call, and both the time the size will be half. So t of n, if the total complexity of the merge sort is t of n, then it is twice the t of n by 2 and then the big O of n. Yeah? So that will be the total complexity. So make sure that in any recursive programs you have to check it out how many recursion calls, out of all the recursion calls how many are going to call, and of those called what is the size of the input that they are going to call, and plus what is the complexity of the iterative algorithms. Let's continue merge sort. Now the question is how student can write down, yeah, this is what the sentinels. Okay, so well, one part you can see that students will write down exam that these are the boxes, total 6 elements, so 3 plus 3 2 1 1 2 so and so on, and then till to till part, let's use the pointers. Yes, okay, so again it will be a divide part here, and then here to here it will try to merge. Once it is merged, combine, and ultimately you will get the sorted part here. So it's a nice, you can say, from viewpoint of writing, you can use this way and then do it. But now I can see there is one problem in this particular example. Well, here there are total 6 elements, so they have divided in 3 and 3 element. Here again they have divided in half, but here they have taken 2 and 1 element, so 3 by 2. So either you can take as a 1 and 2 element or 2 and 1 element. So here they have taken 2 and 1 element, here they have taken 1 and 2 element. So I think if here they are taking 3 by 2 as a 2 and 1 element, and also here they have to take this 3 by 2 as a 2 and 1 element. So it's supposed to be not 4 and 2 6, but it's supposed to be a 4 2 and the 6. Okay. Again this 4 2 supposed to be combined and the 6 will combine, and then this again 4 2 will be combined first, so it will be written into 4, and then the 6 will be try to join. Okay. Yeah, so make sure that you won't do mistakes like this. Now the second observed mistakes will be that one the student will do here. Okay, so let's here 1 and 5 and 3. So sometime what the students can do is they can combine this 5 and 3, and then they will combine with 1. But make sure that if this is going to be in a recursive call, then this is the wrong. So first you have to combine 1 and 5, that is a correct approach, and once you got the 1 and 5, then you have to combine 3. There is nowhere the 5 and 3 is going to be called first and the 1 will be there. Yeah. So make sure that this type of common mistake you will try to avoid. So let's take another example. You can see here they have taken total 7 elements, so 4 plus 7. Well, that is, you can see the advantage of 2 raised to power, that when you have the number of elements, it is in terms of 2 raised to power, either 2, 4, 8, 16, 32. Your divide will be always equal. So like 4, that is 2, 1, 1, and then so on. But when you have a not 2 raised to power, then it will be a misbalance here and there. That will be, if you want to divide integer, divide, then it will be a 1 and 2 element here, 1 element here side, 2 element here side. But if you are taking other way, like 2 and 1, fine. So if you are want to take a ceiling, you have to take ceiling everywhere. If you want to take flooring, you have to take the flooring of the particular answer everywhere. Clear? So like here, the 3 by 2, they have taken the flooring. So if you take flooring, that is 3 and 2 and 1. So everywhere, if there is, again, every places they have odd values, you have to take the flooring of the values. So if you want to take the ceiling values, because in our algorithms we have used the ceiling values, and by default the C language, that is come with the ceiling value, that if you have a 3 by 2 in the integer, that if you want to try, it will be not give you the 1.5, it won't give you the 2, it will give you the. So this is what the way you can try to do in example solving methods. So that's 2 and 1, and then continue you will get, and ultimately you will get the sorted answers. So make sure that during examples you will not making mistakes like this, and in the program way, because it will be a program, and program always do the same level of divide. And so now the complexity, well, the maybe that we thought, like in binary search, that there will be only one recursion call of size half, but it is wrong. The correct analysis, there are 2 recursion call of size n by 2, that's why t of n equal to 2 t of n by 2 plus big O of n. Now you can use any of the methods like master method or recursion tree method, substitution method, intelligent guesswork, any other method you can use, and you can get the answer n log n. So this is the complexity of a merge sort. Okay, now the question that will arise, what do you mean by best case, worst case, and average case in merge sort, and what is the complexity in all of this case? Now the best case is array is already sorted, worst case array is reverse sorted, average case any other permutation other than the best case and worst case. Now if we take our merge sort, and if we assume there is a best case, do we have any advantage? Well, no, because I don't think in best case again you have any advantage, because let's take this example. In the best case, if this thing is already sorted here, again we to divide in half, so and so on, then continue. So this tree structure will remain the same. It means the complexity will remain the same. Now in the worst case, if this array is reverse sorted, okay, compared to this 82, 43, 38, 27, 10, 9 and 3, that is the input, again the tree structure will be continue. It means the number of recursion call, the process, everything will remain same. There won't be any change in that. So that's why either it is a best case, worst case, or average case, the complexity of merge sort will remain same. It is remain unchanged. It is n log n. That is the reason. So other thing that will be that the quick sorts. Okay, let me just quickly go through what is the problem and what is the particular solutions, that is divide and conquer. So in the quick sort, we have to find the pivot element, and based on the pivot element we have to place the pivot element in a proper place in the sorted array, and then we have get the 2 parts. Now compared to merge sort, in the quick sort you may not get the exact half every time, it is unbalanced. So that's where it is where the quick sort will be picture. Now finding the median. Median means the middle element of the given array. If there is a sorted array, then what this element will be in the middle of that. Now one way is, well, we'll go on making the sorting of the array, given array, that we first do the sorting and then we will get the middle element as the median. But that will give the complexity n log n, because the sorting will come with the cost of n log n. Do we have a better approach than this one? So that's why they are trying to use the median algorithms, that they will divide in a groups of 5 element, finding their median, then again median, median of medians, and then they will continue finding the median element of the given array. Now the third problem, that is the matrix multiplications. In the generally we will do a two, if we multiply two n cross n matrix, the complexity will be n cube, because there are 3 for loop that we have to use it out. Even the same, if we use the recursion, we have to do it total n cube. The question is, can we reduce the complexity? If we use the recursion approach, if we use the divide and conquer approach, then do we have an advantage to reduce the complexity? Yes, you can reduce the complexity from n cube to the lower level. So that is what the matrix multiplication. Now the next part is exponent. Consider that you want to compute 3 raised to 4. So what you can do is, you will write a for loop that will going to be run n time. So ultimately 3 into 3 into 3 and into 3, the total there are n minus 1 multiplication. Generally you have to do it. So the complexity of that particular program will be of n, because ultimately you have to go a for loop. N is the power that you want it. Now the question is, can you reduce the number of multiplications? Let's say if I want to compute 3 raised to 128, do we actually require 127 multiplications? Well, no, we can reduce it. So there is a way in the exponent, the logic that the people are trying is, try to use the binary format of 128, and how many number of ones that you require, generally you can try to do a multiplications in that way. The last one is a multiplying large numbers. So when we have a large numbers that is not going to fit and we have to multiply them, then do we directly do a simple multiplications, or we can use to divide the numbers, bigger number in the smaller numbers, and do something in the divide and conquer strategy and get our answer. That is what the multiplying large integers. Okay? So this is what all of this problem ultimately follows a divide and conquer strategy. Okay? So you can look out at our learning management studio, that's at the LMS, NPTEL lectures, MIT lectures, and any other relevant, even the slides of this lecture, as well as all the supporting slides from which the material is used and the material is observed. Everything is going to be shared at your LMS account. So be updated at the LMS account and you can check it out. These are the other some Coleman book that we are going to utilize, some PPTs that's taken as a support. Yeah. So yes, this is what about. So be stay at home, be safe. Yeah. Thank you.